Welcome to this episode of Operating the DECam Community Pipeline. Today's episode will be about starting the pipeline from the very beginning. In my setup here, what you see are terminal windows. The DECam Community Pipeline is primarily operated as a command line Unix environment. I've logged into the host DEC01 of the cluster of machines used to operate the DECam Community Pipeline. Any node could be used, but DEC01 is traditionally used as the operator's head node. The pipeline is a distributed pipeline that runs on a cluster of Unix hosts. The first step is to define which host will be used to run the subpieces of the pipeline. That is done with an environment variable proc nodes. When you log in, there's a default set of proc nodes. Proc nodes is a comma-separated list of host names, which in our cluster are all DEC and then a 2-digit number. Currently, we have 42 machines that are used, though they have different properties. The proc nodes can be set on the command line by the operator with setEnv, but the default is set with during login by the CSHRC file. You will notice various commands I type that are actually aliases. So ed is my interface to an editor, which in this case is VI. What this login process does is it defines two classes of hosts, DEC nodes 12, which are 12 core machines and are the most powerful machines, and DEC nodes 4, which are 4-node machines, or else ones that we want to use as with a lower level of capacity. One thing to note is that not all nodes have to be used, and in particularly some that are less robust are left out. You can study that way of defining these nodes to get DEC nodes 12 and DEC nodes 4. And this is where proc nodes is being set as the combination of all the allowed 12 core nodes and the allowed 4 core nodes. So that's where this came from. So now with proc nodes, we're ready to start the pipeline. The main command that's useful for knowing what is running on which nodes is called PL status. So I'm going to run it just to check that nothing else is running. And what you see is a list of the node names, whether they're connected, meaning whether they're running, and whether the node manager, which is the key component that runs sub-pipelines on each of the hosts, is running. In this case, you see that everything is connected. All the hosts that are in the proc nodes are connected, but the node manager aren't running because we haven't actually started the pipeline. Starting the pipeline based on whatever the proc nodes is set is done with the basic command pl run. So it's telling us that the proc nodes are as shown. It can clean all of the working directories in case things are left over. There are local working directories and directories in the shared GIP, in the shared file system. The components that have to run in order for the sub-pipelines to run are the name server, the directory server, and the node manager. So all the node managers are being started up on every host. This can take a short amount of time unless something is wrong, in which case the operator has to diagnose why it is not able to connect to some particular node. We can see what is happening with the process check command. And you see it's using SSH to connect to all the nodes and start things. All the nodes have SSH configured so that logins do not require passwords. And this is very important. The pipeline would not run if that was the case. So now the pipelines run and PL status automatically runs at the end. So if we look at this again, we see a node, it's up, the node manager is running, and these sub-pipelines, which is part of the architecture of the community pipeline, are running on this node. Not every pipeline has to run on every node. In this, between DEC 01 and DEC 02, there are fewer nodes, or fewer pipelines running. So at this point, the pipeline is up and running and ready to process data. One window I use to operate the pipeline is intended to run a simple pipeline monitor. In reading the documentation, you will understand that the community pipeline uses a system architecture called the Noir Lab High Performance Pipeline System, and HPPS. And that a key component of that is called the Blackboard, which gives a status of every running process and what state it's in. So it's very useful to have a way to monitor the Blackboard. The command to do that, the basic command is called simplemon. And it can be configured in various ways to show different things. But normally you do not want to show every possible entry in the Blackboard, because that can make things very slow, as it has to check every node for every pipeline. The typical operating mode is to just have a few shown, and an alias. There are various aliases, including alias G, that configure it for specific purposes. SM is the one I'll show. The alias starts with setting the title bar of this X term. It's actually an XG term. And then it runs simple mon, showing only the top FIL and DTS pipelines. Read the documentation for more about this. This command right now is basically running a PL status again, so that it can know if any piece of the infrastructure fails, then the monitor will show a warning that that has happened. So that can be very useful. And now the monitor is running. It's a simple monitor because the way it works is to clear the screen and redisplay periodically as things change. So it's not a widget GUI kind of monitor, but it works extremely well. Right now, it's not showing anything running. It also monitors the disk space available. 90% of the shared file system is in capacity, and there's 6.8 terabytes of space left. If you're running large data sets, it can approach 100%, which will require the talent of the operator to deal with. Most of the times it's not a problem. So there we are, running the pipeline, and it's waiting to trigger with some data set. Again, check the documentation for further information, and good luck.